Alright, so the last few problems that we're going to look at today, we have to use the change of base formula you learned back in advanced algebra and pre-calc. Because these problems, we don't have logs with base e. We don't have natural logs. We have log base 6, log, there's no base written here, so remember that just means base 10. This should have a y equals here. But in these cases, we don't know how to do the derivative of log base 6. Right? We know how to do the derivative of natural log. So what we can do is use the change of base formula to rewrite these as natural logs, or in terms of natural log. So the change of base formula looks like this. If we have log base b of x, that can be written as log base a of x over log base a of b. So the x goes on top, the b goes on the bottom, and we change the base. We can change it to whatever we want. But in general, in the past, we've always changed it to either log base 10 or log base e, natural log. So if you think back to an example like this, last year, a couple of years ago, you might have done a problem like this, log base 5 of 20. To figure that out, we can use our calculator, but we can't just type it in this way. Right? We have to use the change of base formula. We can write this, and you probably wrote it as log base 10 of 20 over log base 10 of 5. Right? So we can calculate it that way. You wouldn't necessarily have to write the base 10. But this is also equal to, we could change this base to anything. It could be log base 50 of 20 over log base 50 of 5, but that just doesn't make sense for the situation. What we can write it as is natural log of 20 over natural log of 5. Right, so in this case, it helps us to write it using a base of e, or as a natural log. So for these problems down here, we want to find dy dx, but before we do this, right, before we find dy dx, we have to change the log to natural log. We have to change the log to natural log. So for number 13, not doing any derivatives yet, we're just going to rewrite this, y equals natural log of this whole thing up top over natural log of 6. Now at first you look at that and go, oh great, we made it more complicated, now we have to use quotient rule, but we don't have to use quotient rule. This is a constant down here. We're divided by natural log of 6, that's just a number. So it may help you to think of it this way. I'm going to write it as 1 over natural log of 6 times natural log of this whole thing. Right? This is a constant. We don't have to use quotient rule, it would all cancel out. So basically what we can do here is just leave this out in front times derivative of this. So now we're ready to do the derivative. dy dx, we're going to have that 1 over natural log of 6 out in front times derivative of this, yikes, derivative of that, we get 1 over everything in here, x cubed minus 4x squared minus 2, times the derivative of that whole expression. So times 3x squared minus 8x. So our final answer for this one, we're going to end up with 3x squared minus 8x all over natural log of 6 times x cubed minus 4x squared minus 2. Perfect timing.